You have learned that algebraic fractions are fractions that contain polynomials in their numerators and denominators. Do you remember that numerical fractions can be classified into proper fractions and improper fractions? Similarly, algebraic fractions can be classified into proper or improper fractions. How is this done? First, do you remember what makes these fractions proper? It's because the numerator is less than the denominator. For algebraic fractions, we compare the degrees of the numerator and denominator. Let's use a table to do this. Remember that the degree of a polynomial is the highest index of x. Here, the highest index of the numerator is 1, so the numerator has degree 1. The highest index of the denominator is 2, so the denominator has degree 2. For this next fraction, the term in the numerator with the highest power is x squared, so the degree of the numerator is 2. For the denominator, the term with the highest power is x cubed, so the degree of the denominator is 3. What about this fraction? Well, the numerator is 3, a constant, which can be expressed as 3 times x to the power 0, so its degree is 0. And in the denominator, 4x squared has the highest index of x, so the denominator has degree 2. What do you notice about the degrees in each case? Can you see that the degree of the numerator is always less than the degree of the denominator? That makes these fractions proper. On the other hand, let's see why these algebraic fractions are improper. Look at the numerator of this fraction. The highest index of x is 2, so it has degree 2. Look at the denominator. Its highest index of x is 1, so it has degree 1. For this fraction, the numerator is a cubic polynomial, so it has degree 3. And the denominator is quadratic, so it has degree 2. For this last fraction, the numerator is quadratic, so it has degree 2. But the denominator is a product of two factors. What is its degree? Well, one way is to first expand the product and obtain this. So the denominator is also quadratic and has degree 2. So we can see that for these cases, the degree of the numerator is more than or equal to that of the denominator. So that makes these fractions improper. Next, let's learn a little more about improper algebraic fractions. Do you remember that improper fractions can be expressed as mixed numbers or whole numbers? Furthermore, a mixed number is the sum of a whole number and a proper fraction. For example, 5 3/4 is the same as 5 plus 3/4. How can we express improper algebraic fractions similarly? We know that one way to convert 23/4 to 5 3/4 is by long division. And you have also learned long division for algebraic fractions. So we can try using long division on this improper fraction by dividing x squared minus 1 by x plus 2. Remember that when dividing polynomials, we continue until the degree of the remainder is less than that of the divisor. So let's go through this together. First, take the term with the highest index in the dividend and divide by the term with the highest index in the divisor. We get x. Next, multiply x to the divisor to get x squared plus 2x and subtract it from x squared minus 1 to get this. Since negative 2x minus 1 and x plus 2 have the same degree, we continue the long division. Next, divide negative 2x by x. We get negative 2. Then multiply negative 2 to the divisor to get this, and subtract it from negative 2x minus 1 to get 3. Since 3 has a degree lower than the divisor, we stop the long division. Remember, we can now express x squared minus 1 as x minus 2 times x plus 2 plus 3. How do we get back to the single fraction? We can do so by dividing all the terms by x plus 2. Simplify the expressions to get a polynomial x minus 2 plus a proper fraction 3 over x plus 2. Let's see another example. Here, the denominator is a product of linear factors. Is this fraction improper? Let's see. Expand the denominator. It's actually quadratic, so it has the same degree as the numerator. The fraction is improper. To express it in terms of proper fractions, we proceed with long division. First, divide 2x squared by x squared. We get 2. Next, multiply 2 to the divisor to get 2x squared minus 2 and then subtract it from the dividend. Compare the degree of the remainder, which is 1, with that of the divisor, which is 2. The remainder has the lower degree, so we stop the long division. Just as before, we can express 2x squared minus 2x minus 1 in this way. Again, we can divide all the terms by x squared minus 1 and simplify to express an improper fraction as a polynomial plus a proper fraction. Let's summarize the two things we have learned here. First, we saw that algebraic fractions can be classified into proper and improper fractions. A proper fraction is a fraction with a degree of numerator less than the degree of denominator. An improper fraction is one with the degree of numerator more than or equal to the degree of denominator. Second, we learned that improper fractions can be expressed as a polynomial plus a proper fraction.